So we would go with a quick brush up of electromagnetic induction. So remember, last week our major focus is source of magnetic field, how different sources generate different types of magnetic fields. There we worked literally a lot. Now let us try to know something about magnetic flux. You are fond of electric flux, Gauss law and all that you have applied. Whereas magnetic flux also a very similar terminology. Only difference is when you say magnetic flux, you will use that magnetic flux is defined as integral B bar dot ds bar. You take one element over here. Here, this is how your normal to the area is. Say B bar direction is like this. It makes an angle theta. Through this element, flux is B dA cos theta. Simply. Likewise, all such elements we add up, what you will get a total flux through the closed surface. Mathematically, we will represent it like this. Mathematically, we will represent it like this. So, SI system for magnetic flux is Weber and CGS system for magnetic flux is Maxwell. See, ideally, if you take the Gauss law like kind of situation for magnetostatics, you can have isolated positive charge or isolated negative charge, but you will not have isolated monopole. North, if exists, south automatically exists. You cannot have an isolated north or isolated south pole. So therefore, you take any closed surface implies you are enclosing both north and south. Like how the way you enclose an electric dipole, net flux is zero. Same thing here. Okay. Suppose if the field is uniform, there also you have written E into A is the electric flux, that case. In this case, it is B bar dot A bar. Uniform. This is a fundamental. Now you will go with Faraday's experiments. In fact, this is the starting point of whatever the technology that you are facing and that you are seeing right now. In fact, this is the point where that is a starting point for generation of electric current, particularly AC. Now you see what is Faraday observed that when a magnet is moved towards a coil, you notice that there is a current flow. So long magnet is moving relative to the coil, only then there is a current flow. If magnet is fixed, is set fixed with respect to coil, no current flows. Which means when there is a relative motion between the magnet and coil, there is a current flow. There is a current flow, an EMF is induced in that. And that induced EMF induced is called induced EMF, and the phenomena is called electromagnetic induction. And the current is called induced current. Remember, if the coil is closed, only then there is a current flow. If the coil is open, EMF will be induced, but there is no current flow. This phenomena is called electromagnetic induction. Remember, in this particular case, what is happening is if we are attached to the frame of this coil, suppose if the magnet is moving towards, number of lines are increasing at this point. Suppose if the magnet is taken away from the coil, number of lines passing through the coil decreasing. Remember, whenever the number of lines linked with the coil changes in magnitude, EMF is induced. This phenomena is called electromagnetic induction. Same thing you can observe here also. Now you can have a circuit, a coil-like kind of arrangement with a key. Here I am not showing that there is a key there. Once you close the key, there is a deflection noticed in C1. Once you open the key, there is a deflection noticed in C1. So long there is a steady current in C2, there is no deflection in the magnet, in the galvanometer shown in this instrument. Why? Because when you close the switch, it takes some time for the current to grow to the steady value. During this time, flux linked with the coil keeps changing. Similarly, when you put off, the current will fall all of a sudden from some steady value to zero. Suddenly, the flux disappears. So, EMF is induced. and hence current flows. In two ways, you can change flux linked with this coil. Okay. Now the question is very clear. When there is a relative motion between magnet and coil, or when flux linked with a coil changes and EMF is induced, and this is called induced EMF, the coil is closed, current flows through it. Remember, what is the direction of current is not decided by Faraday's experiments. In Faraday did not even explain about that. Faraday explained that EMF induced depends on the rate of change of flux. But direction is not mentioned. The direction is mentioned by Lenz law. Lenz law. You can see here an observer here. When he is going towards the coil, what is happening? See, the direction of the induced current is induced in such a way so as to oppose the chain that produced it. I repeat, the direction of induced current is such that it opposes the chain that produced it. For example, what is that is inducing current here? North pole moving towards the coil. So the induced current needs to flow in such a way so as to oppose this. Means to repel north pole. To repel north pole, what option do you have? You have array. To repel north pole, you require north pole. So therefore, this north pole will be repelled by this induced north pole. So the induced current. So an observer here sees that the current flows in this direction, anti-clockwise sense. Suppose he is doing a reverse, moving away, you should be stopped. Attract. So in that case, south. So therefore, in that case, the direction of the current is clockwise. Same magnet, same coil. Effects are different. Why? Because your effects are different. In one case, you are making the magnet to move towards the coil. In the other case, you are making the magnet to move away from the coil. In both the cases, what is happening? The induced current is induced in such a way so as to oppose the chain that produces it. This is how. So finally, I can say the EMF induced is minus d phi by dt. Okay. So this is, remember, electromagnetic induction, law of electromagnetic induction. This is Faraday plus Lenz law. Now I have some point to discuss here. Now let us take some coil. I am taking some coil where there are some lines of forces. So long the lines of forces are fixed, there is no change of flux, no EMF is induced and no induced current. Agreed? Boys and girls. Agreed? Suppose inward flux is increasing, then there is an EMF induced. But see, sign conventions are important here. For this, don't forget, I will introduce two different sign conventions. Nidhi, two different sign conventions. You need to use the left hand, you need to use the right hand. Increasing flux, use the left hand thumb rule. What is the left hand thumb rule? Set the thumb in the direction of flux. Here in this case, thumb is inwards. Left hand thumb is inwards. The curl of the remaining four fingers gives you the direction of the induced current. So the induced current in this case is anti-clockwise. Anti-clockwise. Any doubts? Pakka? Right. You take the other case. To take the other case. Suppose if the flux is decreasing, you take right hand thumb. Right? Now set the right hand thumb into the plane of the paper. The curl of the four fingers is in clockwise sense. In that case, direction of the current is clockwise. No change of flux, no current. Flux increases. Set left hand thumb in the direction of the flux. Curl of the four fingers gives you direction of the induced current. For increasing flux, use the left hand thumb. For decreasing flux, use the right hand thumb. This is the thumb rule. Any doubts? Boys and girls? Pakka. Right. Now see how flux will change. That also you need to have an idea. I am not discussing this because I have explained with inward flux. What if it is outward flux? Rule is the same. Right. How can I change the flux? How can I change the flux? I have three options. Flux is B bar dot A bar. B, A, cos of the angle between them. Right. One, I'll move the coil. That comes under motional EMF. Two, I'll rotate the coil. Rotation based EMF. Three, I will neither move, Nidhi, nor rotate. Then how is it possible? With respect to time, I will change the magnetic flux. I will fix the conductor and change the flux with respect to time. First two cases, maybe magnetic field is constant with respect to time. The third case, coil is fixed, magnetic field is changed with respect to time. In that case also, flux changes, EMF is induced. The entire chapter for this week, I will deal only these three concepts, that's all. You ask whatever you want, I'll discuss any of the three, that's all. So let us start with motional EMF. Let us start with translational case, first case. Can you see an inward uniform magnetic field in the region of the space there? All this is inward, inward, inward. Any doubts, boys and girls? Now you have a conductor. This one is the conductor. This conductor is moving with velocity v. An electron in this conductor is also moving with velocity v. Now apply Fleming's left-hand rule for the determination of force. Hold on, don't get confused. I know I'm dealing with negative charge. Last I will express. Fleming's left-hand rule. Inward field. Pointing finger inwards. Right. Okay. Central direction of motion is represented by central finger. Central finger rightwards. If it is a positive charge, it experiences upward force. Since it is a negative charge, it experiences downward force. So this makes accumulation of electrons at this end, accumulation of equivalent positive charge at that end. Conserve charge. Any doubt till this point? Every student in this class. I'll explain. An electron here will experience downward force. Agreed? Paka? So because of this force, more electrons will shift towards this side. To make the conductor electrically neutral, an equivalent amount of positive charge need to shift upwards. Particular case, the rod, you can see accumulation of negative charge is happening over here, accumulation of positive charge is happening over. Now, because of this charge separation, there exists an electric field like this. Now the same electron earlier experiencing magnetic force downwards will experience electric force upwards. Remember, this won't happen for years. It is an instantaneous process. The moment when you start, it happens. Nidhi, till this point, any doubt? Nidhi, when will we do mistakes in exam? Tell me. When we compromise in learning process. Maybe. Likewise. అంత అయిపోయింది ఎగ్జామ్లో స్ట్రైక్ కాదు మనకి రెండు నేను చెప్పడానికన్నా ముందరే మీరు ఏదో చేసేసే ప్రయత్నం చేసినా కూడా మీరు జీరో నాలెడ్జ్తో కంప్లీట్గా వింటే యూ కుడ్ అప్లై ఇట్ ప్రాపర్ రైట్ ఓకే నో ఇష్యూస్ సో వాట్ ఈస్ ద ఎక్స్ప్రెషన్ ఫర్ మ్యాగ్నెటిక్ ఫీల్డ్ ఫోర్స్ అగ్రీడ్ విత్ దిస్ agreed with this agreed with this you want net force 0 v bar cross b bar plus e bar must be 0. In return, I'm not stealing anything away from you. Remember here, V bar cross B bar plus E bar is 0. Agreed? Boys, that can further be written like. Right. What is the definition of potential difference? Let this point be P and let this point be P dash. What is the definition of potential difference? Vp minus Vp is E bar dot L bar. You know this definition of potential difference. Static, electrostatic based. So E bar means B bar dot V bar dot L bar. So potential difference actually is given according to this relation, delta V. B bar dot V bar dot L. B bar cross V bar dot L bar. They are all mutually perpendicular, BVL. If all the three are mutually perpendicular, your length is like this, V is like this, into the plane you have magnet, all mutually perpendicular, BVL. I'm asking you again, do you have any doubt? Pakka. Sure. Right. Now, for this purpose, we have a new rule. It is not Fleming's left hand rule. In fact, now it is Fleming's right hand rule. And at that time, vectors are not known to the people. They used to depend on some conventions, like hand grip rule, Fleming's left hand rule. All that are some conventions. This is also a convention. Now you see what is the Fleming's left hand rule, Fleming's right hand rule, correction. I repeat, Fleming's right hand rule. Now stretch the first three fingers of your right hand. Central pointing finger as it is magnetic field. Thumb should represent direction of motion of the conductor, and the central finger will represent the possible direction of the induced current. Remember, moving object acts as a battery. Inside the battery, current is always from negative to positive. So therefore, if this is the situation, this acts as a battery, and this is how you are expected the source of EMF. The moving object will now behave like this. Why? Because Fleming's right hand rule. How? Fleming's right hand rule how? Are inward you have field. Pointing finger you set like this. Thumb is in this direction. This is how central finger is directed. Right or not? So that represents direction of possible current inside the battery. Inside the battery means minus to plus. Clear? Suppose if the conductor is in some arbitrary shape like this. Some arbitrary shape. Simple. Now you take only 2 points. What is the direction of velocity? This is the direction of velocity. What is the perpendicular component of the length? Actually, this is the perpendicular component of the length, irrespective of the conductor, or something project this length onto a line which is perpendicular to the velocity. What is the direction of velocity? This is the direction of velocity. Imagine a line like this and project. ఇక్కడ నుంచి లైట్ వేస్తే దీని ఇమేజ్ దీని మీద ఏం పడుతుంది? Straight line. Straight line of length L. Simply apply BVL. ఇది negative, ఇది positive. Any doubts? Boys and girls? Clear? Right. Now we will start applying things. Just simple basic discussion. A closed loop of wire having shape as shown in the figure. Can you see the shape clearly? Semicircle, rectangle. Initially, that is how the situation is. After half rotation, the situation will change to here. They are asking what is the change of flux. Simple. Initially, both areas gets added. Later, rectangle area minus half circle area. So what is the difference of the flux? That's what I have taken. It is B into pi r square. Any doubt? The very basic question is what I have done. So what I have done here is a very basic question. Next question. Figure shows a toroidal solenoid whose cross section is a rectangle shape. Find the magnetic flux through this cross section. Through this cross section means through this portion. If the current through the toroidal wiring is I, total number of turns in winding is N. The inside and outside radius of the toroid are A and B. A is this part. B is this part. And height of the toroid is equal to H. Right. Now, hold on. Now, if you allow me, I am showing you the picture here like this. No, take one element over here. This element is at a distance x, whose width is dx. Right. You said the height of toroid is h. Right. How to deal the magnetic field point here? Ampere's law. So if I apply Ampere's law for this loop, integral p bar dot dl bar is mu naught times number of turns times the current enclosed. Right. B into 2 pi r, in this case 2 pi x, mu naught ni. So B is mu naught ni by 2 pi x. That is not my criteria. My criteria is flux. What is flux? D phi is P H dx. Agreed? Boys and girls, say slot area anta dx into h kada. Akada field B. Right. Now integral this. Total flux is x is equal to A to B. So mu naught ni h by 2 pi lageste, you will have A to B 1 by x dx. So phi becomes mu naught ni h by 2 pi log E B by. Any doubts? Pakka? Very simple question. There is a flux. Because, sir, why you are focusing on flux? First, we need to know how to determine flux. Thereafter, you will find rate of change of flux. Got the point? Next. Now, this question again. It's a very repeated question from our side. Read the question carefully. Read the question 2 times before you solve. Initial flux calculation, easy. Final, that 90 degrees one is very difficult. ఇది అర్థమవుతుందా? నిజంగా ఎవరు రాలేదు ఇవాళ? ఒక అమ్మాయి రాలే, ఇద్దరు రాలే. పోయి ఐపీ ఉంది వాళ్ళకి, క్లాసెస్ వినమని ఆన్లైన్ రికార్డెడ్ రికార్డ్ అవుతుంది. బాయ్స్, ఎనీ డౌట్స్? ఇది ఎనీ డౌట్? అసలు మీరు క్వశ్చన్లు చేస్తున్నారా నా డౌట్. ఫస్ట్ పార్ట్ ఈజ్ ఈజీ. కెన్ యూ ప్లీజ్ గైడ్ మీ ఇన్ డూయింగ్ ఫస్ట్ పార్ట్? First part is an infinite long straight current carrying conductor, right? Right. That is the situation. I need to change the color now. Please help me in understanding this question further. The small flux is, they're asking the magnetic flux through the frame. At this point, what is the flux? At this instant, what is the flux? Mu naught by 2 pi I by x a square, no, L dx. Do the integration properly. You will get mu naught by 2 pi I L log E. Or here, how far is L plus A to A? So L plus A by A. Basically, in this case, it is an inward flux. Minus. Minus sign indicates inward flux. Here, there is no issue. All your problem starts when it turns by 90 degrees. In that case, you do the problem from this side. In that case, I will see an outward current carrying conductor, and I have a line like this. The line like this. Remember, this distance is A and this distance is L. Most complex situation we are facing right now. How? For example, try to please understand. Now you choose some element over here. Some element over here. And let this makes an angle theta. Or else I'll do like this only. I'll take this as x, this as dx. That is better. Correct or not? Now, what is going to happen in this case? This is a d theta. Please try to understand at this point, due to an outward current carrying conductor, can you please tell me what is going to be the direction of the magnetic field? Right hand grip rule. It's an outward current, curl, which means this is how you will have B, almost 90 degrees. Almost 90 degrees. If this is theta, this is also theta. Agreed? Yes or no? Now try to please understand. You are asking me flux again. Right. Now you are asking me flux in that case. No issues. If this is a theta, component wise you need to resolve, no? This will become B sin theta. That is B sin theta component. So therefore, the small flux in that is, एक minute. D phi is equal to d sin theta into dx into L. Right. What is B according to you? If this is X, or this is X by sin theta. Agreed? Hypotenuse. Mu naught by 2 pi I by X by sin theta into sin theta. How do I know dx? A is fixed. X is equal to A tan theta. Agreed? Boys, X is equal to A tan theta. Dx is A tan theta differentiation. Secant square theta t theta. So therefore, you can write that as A secant square theta d theta into L. So by proper adjustment, you will have mu naught by 2 pi I by RR, again X is there. X can also be written as A tan theta. X by sin theta into ఎవర్రా చెప్పింది sin square theta by x. ఒక్క నిమిషం ఆగు. X అంటే A tan theta. తర్వాత ఇదేమో A secant square theta into L. ఇప్పుడు నాకు చెప్పండి జాగ్రత్తగా, యూ కెన్ స్ట్రైక్ ఆఫ్ A by 2 pi I sin square theta secant square అంటే tan square theta ఒక tan theta 1 by tan theta అంటే cot theta. sin square theta secant square theta tan square theta అనేగా పైన tan theta వస్తుందా? రైట్, ఓకే. You need to do the integration of this. Now, what is integral tan theta d theta? Any log? అంటే ఇప్పుడు log లో secant theta వేసి చేయాలి మనం. అంతేనా? లిమిట్స్ వేసుకోండి. థీటా 0 2 ఇక్కడికి వస్తే థీటా ఏమవుతుంది? అది ఏఎల్ అవుతుంది థీటా. ఇక్కడికి వస్తే థీటా ఏమవుతుంది? tan ఇన్వర్స్ ఎల్ బై ఏనా? రూట్ ఎల్ స్క్వేర్ ప్లస్ ఏ స్క్వేర్ వస్తుంది ఇది. థీటా 0 నుంచి థీటా ఏమొస్తుంది అంటే రూట్ ఎల్ స్క్వేర్ ప్లస్ ఏ స్క్వేర్ బై ఏ సెకండ్ ఇన్వర్స్. సో దట్ ఈస్ వాట్ యూ నీడ్ టు అప్లై. అప్లై చేస్తే వస్తుంది. దట్ ఈస్ ద ఫస్ట్ పార్ట్ ఆఫ్ ద క్వశ్చన్. Mechanical work to be performed to the frame through an angle, initial magnetic moment, final magnetic moment కట్టుకోవాలి దానికి. అంటే మనకి అది ఇంకోసారి డిస్కస్ చేద్దాం. నెక్స్ట్ సెట్లో డిస్కస్ చేద్దాం. మనం బేసిక్స్ డిస్కస్ చేస్తున్నాం కాబట్టి ఇది కానివ్వండి మనకి. రైట్. A square loop of side L having resistance R moves with constant velocity V throughout the constant magnetic field as shown in the figure. Find the magnitude and direction of induced current in the situation. Let us take that this is situation 1, this is situation 2, and this is situation 3. Agreed? Right. Now, in this case, it is an inward flux. Apply Fleming's right hand rule. Okay. Inward flux, thumb represents direction of motion, right hand side, central finger is upwards. So in the position 1, the arrangement this is how you have the arrangement. Girls, BVL. Side and the L right, BVL. Any doubts? Or I just have a doubt. Is there any problem with the pen or just want to see that? Right. BBL. Yes. What do you want? Direction of the induced current is like this. Position 1. Position 2. Current is 0. Why current is 0? There is no change of flux. Individually, left and right arms contribute, but net is 0. That is position 3. So in this case, this is how the current flows. Okay. So in this case, the current is BVL by R in which direction? Anti-clockwise. Current is 0 in this case. Current is BVL by R clockwise. Any doubts? Pakka? Sure? Right. Not only that, I think it is good that I find flux also. Now, for example, it has entered by a distance x here. What is the flux linked with this? Minus BLX. Negative flux. What is d phi by dt? Minus BL dx by dt. EMF is minus d phi by dt. ప్లస్ బిఎల్వి ఎప్పుడైనా ప్లస్ వచ్చింది అంటే దాని అర్థం యాంటీ క్లాక్ వైస్ అని అర్థం. ఓకే, సో యాక్చువల్లీ దిస్ ఈస్ ద కేస్. ఇఫ్ యూ ప్లాట్ ఎ గ్రాఫ్ హియర్, ది ఫ్లక్స్ increases, steady decreases. For example, we will take the arrangement as some 3L, for example. When X reaches L, flux reaches maximum. Till 2L, there is no change of flux. It's a constant flux. Till 2L to 3L, flux decreases. Right? EMF graph. What is EMF graph? EMF graph, first is clockwise, next 0, next the graph is like this. Next the graph is like this. Any doubts? Pakka? Sure? Right. This is red line represents EMF. Flux, EMF. Both are in same graphs. Doubts? Any doubts? Next. Similarly, we will work on rotation part, rotational based EMF. I am introducing the topic now. Okay. I am introducing actually. Now you see the rod rotating in this case about a fixed axis. My focus is only on single element. Even at this instant, this element has a linear velocity v. That element alone will now act as a rod with the lower end minus, upper end plus, because the explanation I have already given. The EMF contribution by this element is BVL. BV represents R omega. Length of the element is D. All such EMFs you add from 0 to L. You will get B omega L square by 2. Again, here also direction is imparted. Same, if the rod is moving inwards, my lower side minus, upper side plus. Here, hinge side minus, the edge side plus, free end side plus. Suppose if it, see, remember inward clockwise, inward clockwise, inner negative. ICIN, inward feed, clockwise rotation, inner end negative. ICIN. ICICI బ్యాంక్ లా గుర్తుపెట్టుకోండి. ICIN. Inward, clockwise, inward, negative. Suppose you want to have a different version. Inward, anti-clockwise, inward, positive. IIP. IIP. Inward, anti-clockwise, inner edge, positive. As are very difficult. Okay, follow this. Inward, clockwise, center negative, edge positive. Inwards, anti-clockwise, center positive, edge negative. Likewise, 4 combinations. Any doubts? This is the basic concept. A very basic concept. If you are compromising here, you will not understand anything. In fact, I have posted your notes a long time back with all these areas written and only questions opposite to the question I have left some space. Xerox తీయించుకోవాలి ఇంకా మీద. వీళ్ళ గర్ల్స్ దగ్గర ఒక్కళ్ళ దగ్గర లేదు. ఇది పక్కన అమ్మాయి నీ పేరు చెప్పి మర్చిపోయా. కొడతావు కూడా నన్ను ఎప్పుడో ఆ పేరు గుర్తుండదా? ఎందుకు నీకు ఆ పేరు సూట్ కాలేదు? లేకపోతే నాకు గుర్తుండేది కదా. ఫల్విత పేరు నాకు గుర్తుంటుంది కదా, నీ పేరు ఎందుకు గుర్తుండట్లేదు? పేరు సెట్ కాదని. ఆడు గౌరవ్ రాలేదు ఎందుకురా? టెంపరేచర్ పెంచమాట. గౌరవ్ ఏడి? గౌరవ్ ఏ సేమ్ ప్రాబ్లం ఐపీ ఉందా వాడికి? అమ్మా మరి ఎందుకు రాలా? కవర్ చేయడం సాధ కాలేదట. ట్రై చేయండి. ఇది హెచ్సి వర్మ క్వశ్చన్. Ravi Mari. Yeah, try this question. You can see that a conducting circular loop of radius. ఇది ఫస్ట్ అనేసుకుందాం అన్నమాట ఏంటి సిచ్యువేషన్ అనేది a uniform perpendicular magnetic field B, a thick metal rod OA is pivoted at the center O. The other end of the rod touches the loop at A. The center O and a fixed point C on the loop are connected, right, by a wire OC of resistance R, right. Uh, a force is applied at the middle point of the rod OA perpendicular so that the rod rotates clockwise at a uniform angular velocity omega. Find the force. ఇందులో చాలా ఇబ్బంది ఉంది ఫస్ట్. ఇది ఏం కేసు నాకు చెప్పాలి. ఏం కేసు ఇది? ఇన్వర్డ్ క్లాక్వైజ్ ఇన్వర్డ్స్ నెగటివ్. కాబట్టి ద ఎండ్ ఓ మస్ట్ బి నెగటివ్. ఏ అన్నా సి అన్నా ఏదైనా ఒకటే గుర్తుపెట్టుకోండి. Because all that is a conductor కదా. A or C, wherever A is, A and C same potential. కాబట్టి A or C represent the same. O to C are connected with resistance R. Right. Now this is how the current flows. Right. So you can see that the direction of the current flow inside is like this. Now you take OA outside now. OA. You take one element at a distance R, dr, R and dr. Okay. Now the current is in this direction. Fleming's left hand rule again. Magnetics was the left hand rule. Induction was the right hand rule. Inward feed, central finger rightwards, thumb upwards, DFB. Therefore, what is DFB? DFB is mu BIL. DFB is BIL. Can you please help me? What is I? B induced EMF. Current is induced EMF by resistance. Can you please help me? What is induced EMF in this case? ఇప్పుడు ఇచ్చాను రిలేషన్ హాఫ్ బిఎల్ స్క్వేర్ ఒమేగా. ఇక్కడే ఉంది ఇదిగో హాఫ్ బిఎల్ స్క్వేర్ ఒమేగా by resistance. So therefore current means P L square omega by 2 dr by R. R resistance అక్కడ. ఇంత వస్తుంది డిఎఫ్బినే. ఓకే, నెక్స్ట్ టార్క్ ఆఫ్ దిస్ ఆర్ టైమ్స్ డిఎఫ్బి. సో ఓవరాల్గా ఇదేమవుతుంది, బి స్క్వేర్ ఎల్ స్క్వేర్, అలా అవుతూ చెప్తాను, ఒమేగా బై 2r ఇన్సైడ్ ఏమొస్తుంది, ఆర్ డిఆర్ 0 to L. ఇదే వస్తుంది బి స్క్వేర్ ఎల్ క్యూబ్ ఒమేగా బై 2r. ఇదేంటన్నా ఇది టార్క్, టార్క్ ఆఫ్ ది మ్యాగ్నెటిక్ ఫీల్డ్. ఎందుకు ఎల్ స్క్వేర్ బై ఎల్ పవర్ 4, రైట్. ఎందుకు బై 4? లేదు లేదు, ఎల్ స్క్వేర్ బై 2 బై 4 కరెక్ట్, బై 4. ఇక్కడ కానీ డౌట్ ఉందా ఎవరికైనా? పల్విత ఏమైనా డౌట్ ఉందా? రైట్. వాట్ ఈస్ ద టార్క్ ఆఫ్ దిస్ ఫోర్? సింపుల్లీ ఎఫ్ ఇంటూ ఎల్ బై 2, టార్క్ ఎక్స్టర్నల్. అరే ఒమేగా కాన్స్టెంట్ కావాలంటే కండిషన్ ఏంటి? నెట్ టార్క్ 0 కావాలి. సో టౌ బి ఈజ్ సేమ్ యాజ్ టౌ ఎక్స్టర్నల్. సో బి స్క్వేర్ ఎల్ పవర్ 4 ఒమేగా బై 4r ఈస్ ఎఫ్ ఇంటూ ఎల్ బై 2. So therefore from this you can give me the value of f. Any doubts in this? So f is p square l cube omega by 2r. You are asking me the value of f actually. Please go through the different stages involved in the question. First, estimation of current. 2, identifying the magnetic field force as one of the source here. 3, determining the torque. 4, net torque equated to 0. These are the different stages involved in the question. But if you still have a doubt, please ask me again. Boys and girls, do you have any doubt in this? No. All are H.C. Verma problems only. Right. Please see question number 60 and try to answer this. Consider the situation shown in the figure of the previous problem. Can you see that? Suppose the wire connected to ONC has zero resistance. Fine. అంటే ఈసారి ఓకి సికి రెసిస్టెన్స్ లేదు. O potential is same as C potential. But there is resistance for the rim. But the circular loop has a resistance are uniformly distributed along its length. The rod OA is made to rotate with uniform angular speed omega, yeah, shown in the figure. Find the current in the rod when angle AOC is 90 degrees. AOC. Now very simple. In this case, O or C represents the same. Even now my point is the same. A. Right. Between AC. See, please try to understand. O or C is the same. Don't forget that. And in this case, what is that you need to notice is O to A. This is how the rod behaves. O to C, it's a conductor. C to A, R/4 one side. On the other side. Yes or no? So what is R effective now? R effective is ఏ దగ్గరేగా ఇదేగా ఏ టు సి టూ డైరెక్షన్స్ లో వెళ్ళొచ్చు నువ్వు. ఎస్ ఎగ్జాక్ట్లీ. ఓకేనా? ఒరే ఇప్పుడు చూడండి, నేను బొమ్మలో చూపిస్తాను మీకు. R/4 బొమ్మలో చూపిస్తాను. ఇది R/4, ఇది 3R/4. అరే ఒక్క నిమిషం రా, దీనికి ఏదో మాయరోగం వచ్చింది. గ్యాప్ మార్చుకుందాం. యాక్సెప్ట్ చేస్తుంది. That is the picture. Are we clear? Akka? Now the question is, yes, find the current in the rod when the rod when it makes an angle AOC. Okay, R effective మాత్రం చెప్పలేదు మీరు. ఇప్పుడు అది R/4 X అనుకోండి. X 3X ప్యారలల్ అయితే 3/4X అవుతుంది. సో 3R/16. It is not problem with the pen. It is a problem with iPad only. Right. So what is the current? Current. Find the current in the rod. EMF induced by R effective. P L square omega by 2 times 3R/16. This is nothing but 8BL square omega by 3R. Any doubts, boys and girls? Pakka. Do the next question then. Do the next question then. See, all these are H.C. Verma questions only. Just give me a minute time. Just give me a minute time, please. Keep working that question. So you consider a variation of the previous problem. Suppose the circular loop lies in a vertical plane. Vertical plane. The rod has a mass M, and the rod and the loop have negligible resistance, but the wire connecting O and C has a resistance R. Rod is made to rotate with uniform angular velocity omega in the clockwise direction by applying a force at the midpoint OA. See, try to please draw. I am drawing only the free body diagram of the rod. Remember, that is a free body diagram of the rod. And you are applying one force like this. F. At the midpoint, right? And remember, it is in a vertical plane. So obviously, one more force acts mg. Remember, it is rotating like this about a hinge. Any doubts? Pakka? Sure? Right. Now, all this is fair, right? Of course, previously what I suggested is that there is some resistance. మీకు ఎందుకని నేను ఎదురాస్తే ఏదో సలహాలన్నీ ఇస్తూ ఉంటుంది అది. Right. And by the way, omega must be maintained constant. My goodness. అరే మళ్ళీ నేను ఎఫ్తో గీయాలని అనుకోవద్దురా ప్లీజ్, రా కష్టపడి తయారు చేసుకున్నాను అక్కడ. లెట్ మీ కాపీ దిస్. ఫస్ట్ ప్రాబ్లం అందులో ఉండదు, ఇందులో ఉంటుంది. ఐ చేంజ్డ్ ది ఇన్స్ట్రుమెంట్. Torque of B we have done already in the previous question. What is that? B square L cube omega by 4 R. Any doubt till this point? Boys and girls. L power 3 L power 4 R. L power 4 L power 4 ఇందాక కూడా అదే చేశాను మిస్టేక్ 4 right. Arey tau b is done. Agreed, boys and girls. And apart from this there is and remember this is in which sense? Anti-clockwise sense. F is external torque F into L by 2. In which sense it is? Clockwise. And by the way, you are asking, what is that? Ravindra, find the magnitude of this force when the rod makes an angle theta with the vertical. And therefore, torque of the weight force, mg, sin theta, L by 2 sin theta. And this is in which sense? Clockwise. Clockwise. అంతేనా అంతా బాగానే ఉంది ఒక పాయింట్ మర్చిపోకూడదు ఇన్ని టార్కులు ఉన్నా ఏమవుతుందట అది ఆ లైన్ పట్టుకోవాలి ఇప్పుడు తర్వాత మళ్ళీ ఎక్కడి నుంచి వచ్చిందంటే నేనేం చెప్ప యూనిఫార్మ్ యాంగులర్ వెలాసిటీ clockwise direction by applying a force at the midpoint OA. Till this point, any doubt? Boys and girls. So you want a condition where net torque is equated to 0. So tau net must be equal to 0. Tau net 0 means b square L power 4 omega by 4R must be equal to FL by 2 plus MGL by 2 sin theta. రైట్ రే నువ్వు క్లాసులో కూర్చోవటం ఫస్ట్ నేర్చుకోరా రెండో ఒకటి మధ్యలో ఒకటి క్లాసులో కూర్చోవటం నేర్చుకోనరా చిన్నపిల్లల్లా ఏంట్రా అసహ్యం కాకపోతే అందుకే నేను నెక్స్ట్ వీక్ నుంచి ఇంతమందిని కూడా పిలవను 5-6 పిలిచి నేను చెప్పుకుంటా హాయిగా నెక్స్ట్ వాట్ యూ వాంట్ ఫైనల్లీ ఎఫ్ యూ వాంట్ సో ఎఫ్ ఈజ్ ఫైనల్లీ ఎల్ఎల్ క్యాన్సిల్ 2 కూడా క్యాన్సిలే బి స్క్వేర్ ఎల్ క్యూబ్ ఒమేగా బై 2R మైనస్ ఎంజీ సైన్ థీటా చూసుకోండి మీకు అక్కడే ఆన్సర్ ఉంది వాడు ఏ తీసుకున్నాడు ఎల్ ప్లేస్ దట్స్ ఆల్ ఎనీ డౌట్ హియర్ ఐఎమ్ రైటింగ్ ఎల్ యాస్ the length of the rod. Length of rod. Till this point, any doubts, boys and girls? Nidhi, Pakka. Next. Yes, this is a very jumbo question. This is also a HC Verma question. Read the question carefully. చూడండి ఎంత ఉన్నా చాలా సింపుల్గా చేయొచ్చు లైన్లను బట్టి మనం క్వశ్చన్ డిసైడ్ చేసుకోవడం నిన్న కూడా పేపర్ అంతా సెకండ్ పేపర్ డిఫికల్ట్ ఫస్ట్ పేపర్ ఈజీ అన్నారు నాకు ఫస్ట్ పేపర్ టైం ఎక్కువ పెట్టింది సెకండ్ పేపర్ 45 minutes పెట్టాను గుర్తుపట్టలేదు. శివానికి ఏం చెప్పరా, బాగున్నా? నేను పట్టాను కీర్తన్ వాడి బ్యాగ్స్ వారంటీ కదా. వెరీ గుడ్. ఎక్కడ చదువుతున్నా? ఎలా ఉంది ట్రిపుల్ ఐటీ బెంగళూరు? నువ్వు చెప్పి. ఎస్. Here you have a situation similar to previous problem. All parameters are the same except that the battery of EMF and a variable resistance. And theta is again the angle made by the rod horizontal position. Unlike okay, during the part of the motion, you have 0 to during the part of the motion 0 to 45 degrees. The only forces acting on the rod are gravity and the forces exerted by the magnetic field and the pivot. However, during the part of the motion, the resistance R is varied in such a way that rod అరే ఇది నాకేం అర్థం అవుతుందంటే ఆర్ ఏదో మార్చుకుంటాడు, నీకు ఎదుగురా. ఫైనల్గా మళ్ళీ అవే ఈక్వేషన్స్ రాయటమే. అవి తప్ప ఇంకేం రాయగలుగుతాం మనం? ఓన్లీ డిఫరెన్స్ ఏంటంటే తీటా మారింది ఇప్పుడు. తీటా ఇందాక ఉన్న తీటాకి 90 - తీటా వేసుకోవాలి. వై? ఎందుకు? హారిజాంటల్తో ఇది వర్టికల్తో. సో కాబట్టి మీరు ఎలవ్ చేస్తే కట్, కాపీ, పేస్ట్ ఇంతవరకే కాపీ కొడతాను. Ctrl+C. మీరు చెప్పండి, మీకు ఇందులో ఏమేమి మార్చమంటారు నన్ను? In the place of sin theta, I will change rest everything is okay కదా. ఇంకొకసారి చూసుకుందాం. ఒక్క నిమిషం ఆగు. అది దాన్నే ఉంది, టార్కే కదా. రైట్. You want the net torque to be 0? Means what is that they're asking? Find the value of ఈసారి R అడుగుతున్నాడు. B² L⁴ omega by 4R is equal to F into L/2 plus mg L/2 cos theta. Right. You want R? No issues. So what we need to do is మొత్తం తరమంతా యువతల తీసుకొచ్చి విడేస్తే పోతేగా. అది వాడు చేసింది అదే, వాడు చేసింది కూడా అదే. చూడండి, మీకు యూ వాంట్ రెసిస్టెన్స్. టార్క్ డ్యూ టు. అవునవును. వెరీ గుడ్ అబ్జర్వేషన్ డియర్. రైట్. ఇప్పుడు ఇక్కడ అమ్మాయి చెప్పింది కరెక్ట్. ఏంటి కరెక్ట్ అంటే నేను చెప్తాను చూడండి. బిలో ఇష్యూస్ లేవు, టౌ కరెంట్లో ఇష్యూస్ ఉన్నాయి ఇక్కడ. ఎందుకు కరెంట్లో ఇష్యూస్ ఉన్నాయో కూడా నేను చెప్తాను. కొంచెం బద్దగించారు. యాక్చువల్లీ అక్కడ టోటల్ కరెంట్ డ్రైవ్ చేసేవి 2 ఫ్యాక్టర్స్. అక్కడ టోటల్ కరెంట్ డ్రైవ్ చేసేది 2 ఫ్యాక్టర్స్. ఒకటి ఇది, ఇంకోటి ఇది, ప్లస్ రెసిస్టెన్స్. ఎలక్ట్రిక్ పార్ట్ వరకు సర్క్యూట్ ఇది, ఇండ్యూస్డ్ ఈఎంఎఫ్. కరెంట్ ఏం కావాలి ఇప్పుడు? ఈ ప్లస్ BL² omega/2 divided by R. Equation 1. Any doubt in this? రైట్. మిగతా అంతా మామూలే మళ్ళీ. అంటే వాట్ ఈస్ ద టార్క్ ఆఫ్ బి? ఇందాక కాపీ కుట్టింది. ఇందాక మీరు ఏం చేశారు? బి మనం మామూలుగా మనం డెరైవ్ చేసేటప్పుడు ఇందాక వీ హ్యావ్ డెరైవ్డ్ నో. వీ గాట్ ద ఆన్సర్ ఫర్ దిస్ యాజ్ tau of b is equal to you got integral bi dr 0 to L. Yes or no? Right? Pakka. And all the I term is a constant, B I dr. So you will get B I dr. And torque means force into distance. Or so you will get B I L square by 2. And that is again B L square by 2R times E plus BL square omega by 2. This is tau B. And rest everything as it is. So therefore, what is happening right now in this is just have space constraint. Okay, right. Now, what are the other tasks? Just please, Fatapat, tell me. Tau mg is, instead of mgl by 2 sin theta, you will write mgl by 2 cos theta. Tau of external force. Is there external force now this time? Yes. No, there is no external force. And there is no F term involved. That's all. Only these two forces. Done. No external force involved. Now, this is in which direction? This torque is in anti-clockwise. This is in clockwise. So, net 0. You want resistance term, don't forget that. BL square by 2R times 2E plus BL square omega by 2 is mgl by 2 cos theta. So which implies the resistance is BL square L because here 1 square and here L. So BL by 2mg cos theta times 2E plus BL square omega. That is what the resistance. So you should change your R all the time to have this. Sir, what are variables in this? What are variables in this? Geetika, what are variables in this? B, not a variable. L, not a variable. E, not a variable. Omega, you want omega to maintain constant. So what changes? Theta. Theta. So according to theta, you should change R. So any doubt in this, please ask me right now. Clear? Pakka? Sure? All these are from H.C. Verma. Right. A very good question again. H.C. Verma. Please go through this question again. A wire of mass M, length L can slide freely on a pair of smooth vertical rails. Magnetic field B exists in the region in the direction perpendicular to the plane of the rails. Rails are connected at the top end by a capacitor of capacitance C. Find the acceleration of the wire neglecting any electric resistance. Any electric resistance. Yes. Tell me what exactly is happening. Forget about the capacitor, blah, 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 all that stuff. Now, this rod, while it is moving downwards, Fleming's right hand rule, inward flux, direction of motion, thumbs down. Geetika, thumbs down. Right hand or left hand పెడుతున్నావా? Very good. Central finger, left to right. Central finger is from left to right. This is how the current flows. This is how the current flows. If there is an induced current, means battery minus plus. Now this situation is equivalent to an arrangement like this, connected to a capacitor like this. So always in this case, PVL is Q by C, equation 1. Any doubt in this, please ask me. Now this is the current. Baya, this is the current. Now this will experience two forces. Weight force. Magnetic force చెప్పండి. Magnetic force కి ఏం వాడాలి? Fleming's left hand, inward, direction of motion, thumbs up. FP. So therefore, what you have is mg minus fb is ma. mg minus bil. Okay, hold on. bil is ma. By the way, differentiate equation 1 with respect to time. What you will get? PL dV by dt is 1 by C dq by dt. So wherever I have current, I can write simply I by C. Wherever I have current, I can write as BLC dV by dt. Let this be equation 3. Now use 3 in equation 1. Any doubts to this point? By doing this, what is that you are going to have? By doing this, mg minus b square L square C, okay, b square L square C dV by dt is m dV by dt. So with this I can write as dV by dt is what do you want? The same. Find the acceleration of the wire neglecting any electrical resistance. This is the acceleration. Is this constant or variable? Why it is constant? All terms on right hand side are fixed values. They are all constants. Any doubt in this? Pakka? Sure? Right. Hold on. dq by dt అంటే కరెక్టేగా? అవునరా నాన్న, ఇదిగా డిఫరెన్షియేట్ చేస్తే అదే కదా వచ్చేది. కరెక్టేనా కాదు? కొంచెం మంచి క్వశ్చన్స్ చేద్దాం ఒక నిమిషం. ఈ క్వశ్చన్ స్టార్ట్ చేయండి. ఎక్కడ డిఎక్స్ బై డిటి రాలేక ఒరే ఇప్పుడు దాన్ని డిఫరెన్షియేట్ చేస్తే డివి బై డిటిఏ కదరా వచ్చేది. బిఎల్ డివి బై డిటి ఈజ్ 1/c డిక్యూ బై డిటి. డిఎక్స్ ఎక్కడ వస్తుంది నీకు? యాక్చువల్గా దీని అన్నిటికన్నా ముందు ఇది చెప్పుకోవాలి. మోస్ట్లీ సేమ్, బట్ స్టిల్ చూసుకోండి, మీరే చూసుకోండి. Try this. Two conducting smooth fixed parallel rails system is placed in a uniform magnetic field, direction perpendicular to the inclined. What makes the difference? I think this is still the same question. I don't see any difference. Only difference I could see is in the place of G, I will write G sin theta. Rest everything is the same. So therefore, calculate the acceleration of A is G sin theta by B square L square C by M plus 1. Everything is the same. No change. Right. Yes. Try to do this question. Remember, unlike the previous question, this question B is upwards. We need to do this question carefully. This will be the last question. Smooth conducting fixed parallel rails are inclined at an angle theta to the. See, try to please understand. If I see the arrangement in this sense, conductor seems to be like this. Okay, okay. Second floor second floor 2 minutes class pumping just that's the arrangement. You have, suppose if this is moving downwards. And that's B. ఓకే అరే నాన్న ఈఎంఎఫ్ సోర్స్ ఎట్లా చెప్తారు మీకు? ఈఎంఎఫ్ సోర్స్కి ఇప్పుడు ఫర్ ఎగ్జాంపుల్ కాంపోనెంట్ కదా రిజాల్వ్ చేసుకోవాల్సిందే. ఇది బి, ఇది వికి పర్పెండిక్యులర్ గా ఉండే కాంపోనెంట్ కావాలి మీకు, అవునా కదా? అది ఎలా తెలుస్తుంది మనకి? రిమెంబర్ ఇది 90 మైనస్ తీటా అంటే ఇది తీటా. సో దేర్ ఫర్ ఈఎంఎఫ్ కాంట్రిబ్యూట్ చేసేది పి కాస్ తీటా విఎల్. ఈక్వేషన్ 1. డైరెక్షన్ దాన్నే ఉంది. ఇప్పుడు ఇక్కడి నుంచి చూసేవాడికి ఫ్లక్స్ పెరుగుతుంది, ఇక్కడి నుంచి చూసేవాడికి ఫ్లక్స్ పెరుగుతుంది. ఏ హ్యాండ్ వాడతారు? ఏ హ్యాండ్? రైట్. ఒరే మళ్ళీ మొదలుకు వచ్చారా మీరు? ఇంక్రీజింగ్ కి లెఫ్ట్ హ్యాండ్, డిక్రీజింగ్ కి రైట్ హ్యాండ్ చెప్పింది. ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూల్, అదే రైట్ హ్యాండ్ లెఫ్ట్ హ్యాండ్ గ్రిప్ రూల్. తమ్ము మీ వైపు ఉంది. కర్ల్ ఆఫ్ ద 4 ఫింగర్స్ ఎట్లా ఉన్నాయి? కర్ల్ ఆఫ్ ద 4 ఫింగర్స్ క్లాక్ వైజ్. అంటే ఈ కేసులో ఆ అరేంజ్మెంట్ ఇలా రావాలి, ఇట్లా రావాలి. దేర్ ఫోర్ కరెంట్ వచ్చేసేం వస్తుంది, పి కాస్ థీటా విఎల్ బై రెసిస్టెన్స్ ఆర్. రైట్. ఇప్పుడు దీని ఫ్రీ బాడీ డయాగ్రామ్ మళ్ళీ తీసుకోండి. దీని ఫ్రీ బాడీ డయాగ్రామ్ ప్రకారం కరెంట్ ఎట్టుకు వస్తుంది మీకు? కరెంట్ అవుట్ నా వైపుకి వస్తుంది. యాక్చువల్గా నేను ఇక్కడి నుంచి చూస్తున్నాను కదా, కరెంట్ ఇలా కదా పోయేది. సో అవుట్వర్డ్ కరెంట్ అండ్ ఇది బి. ఓకే, అవుట్వర్డ్ కరెంట్. మళ్ళీ ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూలే. అవుట్వర్డ్ కరెంట్ బి అప్వర్డ్స్. దిస్ ఇస్ ద డైరెక్షన్ ఆఫ్ డిఐఎల్. ఫైండ్ ద స్టడీ స్టేట్ వెలాసిటీ అని అడుగుతున్నాడు. వాట్ ఈస్ ద మీనింగ్ ఆఫ్ స్టడీ స్టేట్ వెలాసిటీ? సింపుల్. అట్ సమ్ పాయింట్ ఆఫ్ టైం mg sin theta, if mg sin theta balances with BAL cos theta, steady state is achieved. So mg sin theta is P into P cos theta VL by R into L cos theta. So what do you have? Resistance. What is that they want? Find the rod is, find the steady state velocity. Velocity is mg sin theta by into R by B square L square cos square theta. Okay, that's all. Any doubts? Right, just go to your class.